Paper 1R, June 2016, question 11. So this question is about forces, resultant forces. It has a hot air balloon tied to the ground by 2 ropes. You are given a diagram showing all the forces acting on the balloon as it's tethered to the ground. It tells you that the upward force is 950, and as it's tied to the floor, the weight downwards is 9,100, and the tension in each rope is 200. So you should hopefully notice that that means that the forces are balanced, and we know that because it's not moving. So you have a total of 9,500 down and 9,500 up. Then it says the ropes are untied and the balloon starts to move upwards. So as soon as the ropes are untied, these 2 forces of tension disappear, and it wants you to state the value of the force acting downwards on the balloon immediately after the ropes are untied. So the immediately after and before it starts moving means that you're going to ignore any forces like air resistance. So it's just the second that the tensions disappear. That means the only force you've got acting downwards is 9,100 weight. Okay. So state the relationship between unbalanced force, mass, and acceleration. If you want to, you can get away with just writing F equals ma, but as we always advise, much better to actually write it out properly using the words, much less chance of you making a mistake. So that would be unbalanced force equals mass times acceleration. Nice easy mark. So the balloon has a total mass of 910 kilograms. The initial unbalanced force is 400 newtons upwards. Calculate the initial acceleration. So they've been very nice here. They've told you which equation to use. So they want you to use this one. They've even reminded you that this is the unbalanced or resultant force. So this doesn't mean that it's the force upwards, it's the actual overall force. So it's just a matter of putting the numbers in. So you need to rearrange it. So it's force over mass, 400 newtons on the top, 910 kilograms on the bottom, and that gives you an initial acceleration of 0.44. Part C, explain how the upward acceleration of the balloon changes during the first few seconds. Now, it was being really clear earlier about the fact that it wasn't moving, it was immediately after the ropes are untied. So it does want you to think realistically, and it wants you to think about the kind of other forces that would be acting on the balloon. So as it's accelerating upwards, obviously it's moving upwards now, the speed is increasing. So the additional force that's going to start acting is going to be air resistance. Now this is for 3 marks, so you need to be quite detailed, and it's an explain as well. So it wants you to first of all state how the acceleration will change. So the first part of any explain question is actually saying how it will change. So as it starts going upwards, first of all, the speed's going to increase. That will get you a mark because it's accelerating upwards. But then as the speed increases, you will start having air resistance or drag forces acting, and they will act in the opposite direction. So that will actually act down because the movement is up. Remember, air resistance and drag always act opposite to motion. That means that your overall force will be less. At the moment, or to begin with, you had 400 newtons upwards, but now because you've got air resistance acting downwards, your overall or your resultant force will be less. And that means that your acceleration will be less. Your acceleration will decrease. Now, the most important ones there are, I think, 2, 3, and 4. Those are the ones you're aiming for. So part D, while the balloon is still accelerating, the pilot controls the balloon by pouring some sand from the bags. Explain how this affects the upwards acceleration of the balloon. Again, so if he's pouring some sand from the bags, what will that affect about the balloon? So it will affect its mass, so therefore it will also affect its weight. So losing the sand will reduce the weight, and the weight is acting downwards. So if you're reducing the force acting downwards, the unbalanced or resultant force upwards will increase again. And if your unbalanced force increases, so does your acceleration.